Welcome to my class once again. Today we would like to solve a question or a few questions on forces. Kindly subscribe to my channel if you find this stuff interesting, because there's going to be a lot of other interesting stuff, and then you can share and like and bring awareness to this platform so that we can be able to let a lot of people enjoy the physics that we are studying here. Now I have a question of a body of mass 200 kilogram, which is placed on a rough horizontal surface. It is on if the body is moved with a constant speed by a force of 20 Newton. Calculate A, the force exerted by the surface on the body, and then B, the coefficient of friction. Now the first thing that you do for such a question is to draw a diagram with your body. Now, once you have a diagram, then it means that the weight is downwards mg. From the question, the weight is equal to 200 times 10. So you are going to get 2000 Newton for the weight. And then we have our normal reaction R. There has been an applied force which is equal to 20 Newton in this direction. Now the question is making it perfectly clear that if the body moves at a constant speed, now once the body is moving at a constant speed, it means that all systems are in equilibrium, and therefore upward forces is equal to downward force, and forces on the left is equal to forces on the right. Aside that, since the surface is rough, then it means that there is also friction in the opposite direction. Good. Now the first question, we are to calculate the force exerted by the surface on the body. If you look at the diagram carefully, you realize that the normal reaction R is the force that is exerted by the surface on the body. So this is equal to the weight mg, and therefore R is equal to 200 times 10. So R becomes equal to 2000 Newton. That is the first question. Then in our next question, you have to calculate the coefficient of friction. We have a relation, or we have already met our relation for coefficient of friction, which F is equal to mu R. The mu is the coefficient of friction, which is equal to F over R. Now we have already said that the forces on the left equals the forces on the right. So it means that the frictional force is equal to the force F, which is equal to 20 Newton. Therefore, the coefficient of friction is going to be 20 all over 2000. You have 1 0 cancelling another 0 here. This goes here 1, this goes here 1. So you have 1 over 100. So the coefficient of friction becomes 0.01. And remember, it has no unit. Since the friction is in Newton and the normal reaction is also a force, which is in what? Newton. We'll move on quickly to our second question for this lesson. We have a body of mass 20 kilogram on a smooth horizontal surface which is pulled by a 10 Newton force at an angle of 60 degrees. You have to calculate the normal reaction, the effective force, and then the C. If the surface is rough and has a friction of 2 Newton, calculate the effective force. This time around, you could see that the question here demands a diagram. So let me just quickly take us through the diagram. I have this, and then we're saying that the weight is downward. So you have mg, the normal reaction is R. This time around, the object or the body is being pulled by a 20 Newton, the force is 10 Newton, sorry, by a 10 Newton force at an angle of 60 degrees. So here, since it is being pulled, then the f of x here is in this direction, and then the f of y is in this direction. So here, f of y is going to be 10 sine 60, and then f of x is going to be equal to 10 cos of 60. So this is the diagram that we are going to have for the question that has been given. I think we can move on from there and then try and solve the rest of the questions that has been asked by our people. So here, let's go through and then see what we can get. The 10 sine 60, you are going to arrive at 8.66 Newton. And then the f of x, that is the 10 cos 60, you are going to arrive at 5 Newton. So I want to just fix this thing into a diagram that we already have for the question here. So I have this one to be 8.66 Newton, and I have this one to be 5 Newton. So the weight is also downwards, which is 200 Newton, so that if I go to my questions, I can just come back quickly and replace whatever I need to replace in it. The first one is the normal reaction. Now, if you look at the question, once there is an angle involved and there is a pull in this direction, then we can say that the normal reaction F plus F sine 60 is equal to the weight W. So if you look at the diagram, you realize that the upward force is this, and then this, and this is the only downward force here. That is how come you have this relation. So the normal reaction R is then going to be equal to the weight minus F sine of what? 60. The weight from the diagram is 200 Newton, and F sine 60 is 8.66 Newton. So if I have 200 minus 8.66, then this is going to arrive at an answer of 191.34. So I have 191.34 Newton. So this becomes my answer for the reaction. Now, the second question B, we have to calculate the effective force. I've already told you or said that the effective force E is the force that moves the object in the direction in which the force or the object is supposed to move. So from here, the effective force is F cos of 60. So from here, we're going to get 10 cos of 60, which is equal to 5 Newton. So the effective force is going to give us 5 Newton. Then there is a condition question, the C aspect. The C aspect is saying that if the surface is rough and has a friction of 2 Newton, calculate the effective force. Here the surface is rough. So when I come back to my diagram, it means that I have a friction which is equal to 2 Newton. So the effective force E is going to be the force cos of 60 minus the frictional force F. So you are going to get 5 Newton minus a frictional force of 2 Newton. Therefore, the effective force is going to be 3 Newton. Please, you can go through this video over again and then enjoy it and see how best you can solve questions on your own. In my next lecture, I'm going to add more to this. Kindly subscribe, share, and like my videos so that you can enjoy my class and then you'll be aware of constant release of videos. Thank you very much.